Hello, welcome to our topic today, and that's probability using counting techniques. So what do you need to do today? What's your learning goal? Well, you have to extend your understanding of basic probability and using counting techniques discussed in Unit 1. So back in Unit 1, we talked about placeholder method, we talked about tree diagrams, we talked about permutations, combinations, clones. We now have to take all of those skills and bring them together in probability. Okay, so that's what we're going to look at. The basic probability formula again is probability of event A occurring is NA over the total number of outcomes, NS. So now we need to move the formula towards dealing with counting concepts. So we know that, let's pull this down a little bit further. So N of A is our number of successes, and N of S is our total number of outcomes. Total number of outcomes. Now the difference here is that we are going to use, we might use factorials, we may use combinations, we may use permutations, we may use placeholder method, we may use tree diagrams, placeholder method. So anything we talked about in Unit 1 is now fair game in this particular unit. Tree diagrams, all right, and etc. Whatever else we can use to solve this. So that's what we're looking at here. We're now expanding or extending it. And we don't even have to use combinations, permutations. This could be our numerator, for example. So this one, we may use combinations to get N of A, but in the denominator, we may be using permutations to find the total number of outcomes. So you got to kind of open your mind to the different methods that exist out there. So 3 coins are tossed one after another. Calculate the probability, A, that 3 heads occur. So there's 2 ways. I'm going to show it 2 ways. So I'm going to look at number 1 here. That's tree diagram. All right, and there's going to be a lot of people here saying, oh, a tree diagram, don't make us do that. No, you don't have to. I'm going to show you the second method. So tree diagram, you'll have your first, second, third outcome. So head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. And that's why some of you are screaming, no! Make sure I get it lined up here. All right, so from the tree diagram, I can get my N of S. So we're just going to extend that out one more there. So for A part, probability of 3 heads, N of A over N of S equals, that view's a little bit better. So N of A, I know my N of S is 8 because if you were to count them, just like we did in the first unit, there's 8 outcomes there. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 outcomes. How many of them produce 3 heads? Well, head, head, head. There's only one pathway here. So there we go. It'd be 1/8. So therefore, probability is 1/8 for that to occur. B part. A head and 2 tails will occur. So, same thing here, moving my way down. B, probability of, can't remember, goldfish memory, head, 2 tails, head plus 2 tails. Looks like 2TI, I don't know what that would stand for, 2T equals, again, N of A over N of S. I know there's only 8 possible outcomes here from the tree diagram, but now I have to find the number of pathways here that would result in a head and 2 tails. So I could go head, tail, 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 head, tail, 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 head. I believe that would be it. So there are three possible ways here for us to get a head and two tails. So I'm just counting the number of branches that produces that particular answer. C part, two coins are tossed at the same time, and the third one's different. So that means that we're looking at pathways that provide us with two being the same. So we already have three labeled here. Those are all the two tail ones. Now we need the two head ones. So that would increase it. There's two heads. Head, tail, head. There's another one. Tail, head, head. So we find what ends up happening here is that we were just eliminating two cases. So we end up with 6 possible pathways then. So the probability of two the same, again, is your N of A over N of S. We know there's 8 outcomes, and now there are 6. So that reduces down to probably not that, maybe 3/4. So therefore, this one needed a therefore statement as well. Therefore, the probability is 3/4. So now what I want to do is I want to demonstrate that there's an alternate method. Some people are going to like the or the tree diagram, and by all means, go ahead and use it. I'm going to call this, I'll call this the placeholder method, same what we did in the first unit. All right. So before I even do A part, N of S, my number of outcomes is equal to 3 coins. And in each case, there's 2 possible outcomes, which gives me my 8. So I know there's 8 possible outcomes. So for part A, probability of, go back to 3 heads, equals NA over NS. I know the total number of outcomes is 8 from above. 3 heads, so again, if I do the off to the side, if it's 3 heads, there's only 1 choice there, 1 choice, 1 choice, which would mean my numerator is going to be 1. So therefore, probability is 1/8. B part, a head and 2 tails will occur. So probability of a head and 2 tails. N of A over N of S. I know the denominator will be an 8. Now I got to figure out, I need a head and 2 tails. So a head and 2 tails. So when I look at this one, I know that the head, I need 1 head, 1 tail, 1 tail. However, it doesn't state the order in which they can occur, so I need to figure out the different possible ways they can be lined up. Since order does not matter, hint, 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 I have 3 items, and I'm going to arrange them in, sorry, my mistake, and we can leave that, it's kind of right. But anyway, what we have is we have a pool. We have 3 items, head, tail, tail. All right, I'm going to cross that out. So we have 3 placeholders. For the first placeholder, I have 3 possibilities. I could pick the H, or I could pick a T, or a T. Then one of those are eliminated. I have 2 items left, placed there, and the last item has to go there. The only thing we have to remember in this case is that we have clones. So this is an example where I'd have to bring in clones. So really my numerator would be 3 factorial from above. I have 2 T's, 2 factorial, which would give me the number 3. So the probability would be 3/8. So therefore, probability is 3/8. And the last one are 2 the same. So probability 2 the same. N of A over N of S. Again, I know my denominator is going to be an 8. So how do I figure out that numerator? A bunch of different ways. You know that we can have head and 2 tails in any order, and we knew that gave me 3 outcomes, and that's from above. So if I flip it, tail, head, head, well, logic would dictate the same thing is true, so there's 3 there. So that means I would have 3 ways to get heads, tails, tails, or head and 2 tails, plus 3 ways I get tail and 2 heads, giving me the 6/8, which reduces down to 3/4. So you can see that everyone's going to approach these questions a little bit differently, and which is a good thing. It gives you the opportunity to see it the way you need to see it. There's not one process you must use here. I'm telling you that there are multiple processes, and there's probably a third one here, using combinations and permutations if you really wanted to, or see it that way. Okay, so there are 2 worked examples. I'm not going to do them all this way in the next couple of videos, because I'm just going to go through and I'm going to use the one that kind of jumps out at me. But for every example I do in the next page or 2, realize that each of those examples can be done a different way. All right, it's just all in how you see your particular solution off the start. All right, so that is what's necessary. You will be using factorials, combinations, permutations, placeholders. So you got to kind of dust off your first unit cheat sheet, or make sure you go through your notes. But anything you did in first unit, it will be done again here. Good luck. Or sorry, I'll see you in the next video here and finish off some of these examples.